Now that we have learned about parallelograms and what creates a parallelogram, we're going to look at three specific types of parallelograms: a rectangle, rhombus, and a square. So first off, for a rectangle, there are three main properties that we need to know about them. And first off, it has all the same properties of the parallelogram. Second, it has four right angles. Lastly, the diagonals are going to be congruent. And remember from a parallelogram that the diagonals are bisected. That means that all four of them are going to be congruent to each other. So not only are the full diagonals congruent, but all four pieces will be congruent to each other. The next shape is a rhombus, and a rhombus will also have all the same properties as a parallelogram. All four sides are going to be congruent to each other, and we have diagonals that are perpendicular to each other. Lastly, for a rhombus, all the diagonals are going to bisect the opposite angle. When you are looking at our picture right here, you can see that happening. So this is the diagonal, and it's cutting the opposite angles in half. Now remember, with the parallelogram, already angle A is congruent to angle C. So with a rhombus, when it goes through the center like that, all four pieces will be congruent. And that is the same for the other diagonal. So all four of those angles will be congruent to each other as well. The last special type of parallelogram that we're going to talk about is a square. And a square is going to have all the properties of parallelograms again. It is also a very more specific type of rectangle and a rhombus. So it's a combination of a rectangle and a rhombus. It has all the properties of a rectangle, being that they have four right angles. It will also have all properties of a rhombus, being that they have four congruent sides. This is the type of question you are going to see multiple times throughout our different notes and worksheets, and that is that we need to classify the four-sided figure, or the parallelogram, as a parallelogram, rectangle, rhombus, or a square based on the information that we have in the picture or that is given to us. And we want to use the most specific name possible. So a square is the most specific. A rectangle would not be as specific. So with this first one, with number 1, we see four congruent sides. And because they tell us that it's 70 degrees for that angle, we do not have any right angles. So because there's no right angles, but we do have four congruent sides, this would be a rhombus. If you are not given a picture, then you need to draw a picture. So let's draw a four-sided figure. It has four congruent sides, so it starts out being like a rhombus, except on this one we're going to have four congruent angles. So we make our four little arcs in our angles. Because it is only four sides and it's a quadrilateral, that means that those four angles would need to be 90 degrees. Since we have four congruent sides and four right angles, specifically, it makes it a little bit more specific than a rhombus. It's going to be a square. And number 3, I would like you to solve this one yourself. So tell me, what type of shape is it, and be as specific as you can. You should have drawn a four-sided figure to help you out. We have four congruent sides, and that's it, and we do not know what the measure of the angles are going to be. So it's kind of like number 1 over here, where it is going to be a rhombus. So hopefully that is what you chose. Number 4, we have a quadrilateral with just the fact that it is four right angles. Because they are right angles, that's going to tell us something else about our picture, that we're going to have some parallel sides. So because we have two sets of parallel sides and all we know that it's a right angles, then we are going to have a rectangle. And number 5, this is just in words. I want you to fill in the blank. So if a parallelogram is a rectangle, then its diagonals are what? So if we go ahead and fill that in off to the side. You should have chosen congruent. So if it is a rectangle, we know that the diagonals are going to be congruent to each other. So next, if a parallelogram is a rhombus, then its diagonals are, and this one should be perpendicular. Number 7, if a parallelogram is a rhombus, then the diagonal blank a pair of opposite angles, and I want you to fill that out off to the side. the word you should have chosen was bisects a pair of opposite angles. Number 8, first we need to classify this picture. And in our picture, I see 4 congruent sides. We also see 4 right angles at the corners. I also see that the diagonals are perpendicular to each other. And the only shape that has all of those pieces would be the square. So because your angles are right angles, that tells us that we have opposite sides that are parallel, so we parallelogram. But because we have 4 congruent sides, that makes it a rhombus. And the diagonal being perpendicular also kind of goes along with your rhombus, but the square has to have right angles and 4 congruent sides, so it is a square for our classification. Next, we need to find the values of x and y. So because we know it is a square, and we see that we have opposite sides are congruent to each other, so these 2 sides are congruent, I can set those equal. So 2x plus 1 should equal 4x minus 7. So when we solve this, if we subtract 2 off of both sides, that gives us a 1 equals 2x minus 7. We can add 7 to the other side. So we get 8 equals 2x. Divide both by 2, and x is going to equal 4. The part that might be a little tricky is right here with our y value, and so you have to look at one of those squares by themselves. Now remember, in the inside part we have a right angle. We also know that if it is a square and it's a rectangle, we know some different pieces about the diagonals. Because it's a rectangle, we know that all the diagonal pieces are going to be congruent to each other, and a square is also a type of rectangle, so we know that this is an isosceles triangle. But if it's an isosceles triangle, that means that each of these degrees are going to be 45 degrees since we already have the 90. That means this 45 right here is equal to the 7y plus 3 because that's where that measure is. So we're going to set up 45 equals 7y plus 3, and now I want you to go ahead and solve it for y. You should have subtracted 3 off of both sides, so you get 42 equals 7y. Divide by both sides by 7, and we get y equals a 6. One little side note going back to our picture, if you notice we do have 4 of these triangles in here, and all 4 triangles are going to be congruent in a square. So any of the different measures that you are going to find within your square, you have 4 different equal congruent triangles, so they will correspond to different pieces. Number 9, it tells us specifically that it is a rectangle, so there's different pieces that we want to know. We know that a rectangle, the diagonals are bisecting each other, and to begin with, the length of them are all equal to each other. So all 4 of those are going to end up being equal to each other. So when we put in the measurement that QS, so the whole length is 18, if we divide that by 2, that gives us that each of these little pieces is going to be a 9 in my diagonal. So if we jump over to our answers, ST, we already have that it's 9. PR is the whole distance, and that would be 18. So moving on to the measures of the angles, we're looking at the 62 degrees, and what I want you to realize is that since we have something we saw recently on the square picture, we have this congruent, not really congruent triangle, but is an isosceles triangle because we've got these 2 pieces, 2 sides that are the same. So if we have 2 sides in your triangle that are congruent, that tells you that these 2 base angles will also be congruent. So this is also 62. And because those are both 62, we can take 180 minus 62 minus another 62 to figure out what our missing angle is over there at T, and that would give us a 56. So in my triangle, this is 56. We have vertical angles, so that is also 56. If we take 180 minus the 56 for a linear pair, we end up with 124 degrees. And that would be, right here is 124, and so is this one, is 124. And we could work out the same way in our triangle up above. In this big triangle, we know it's an isosceles triangle, and we see the 124 degrees already. So that means that these 2 measures have to be equal. if we take 180 and we know that 124, and I'm just going to say it's x for the missing angles, I can add those two missing angles together, and they are the same, so that's why I'm using my x. And I could use this to solve for that missing angle. So if I subtract 124, we get 56 degrees equals 2x. If I divide that by 2, that gives me, let's see, 28. So each of these missing angles up there are 28. Now remember, these are congruent triangles, so this is also going to be 28 and 28. Another way you could find that is because we know it's a rectangle, we know that this angle right here is 90 degrees, so because this is 62, this would also have to be 28. So now if we look at our angles that they're asking us to find in our picture, so QPR is just this one little piece, and that's 62 degrees, just like it is right here. Next is PTQ, and that's this missing angle right here in the middle, and we already found that, and that was 124 degrees. We are going to use similar reasoning to work through number 10, except now we know it's a rhombus. We know on a rhombus that all four sides are congruent, kind of like a square, except the angles and the corners will not be right angles. But I do know that the diagonal bisects the opposite angles. Now remember, the opposite angles to begin with are congruent, so if this is bisecting it, that means that all four of those angles are the same. We already have the 34s, that tells us three other angles will be 34. A rhombus, the diagonals are perpendicular, so I know that all these inside angles are 90 degrees, so it creates 4 right triangles. Because it is a parallelogram, we know the diagonals bisect each other, and we know that this will also be 7. In our picture, 2 letters that were not drawn was the Y and the Z, so add those in real quick. Also in the center, the intersection point is point V, so add those 3 letters in since that was not given to us. So the next thing we're going to do is let's look at some different pieces that they're asking us to find. We're going to save this XY for the last one because that's probably the trickiest question on there. But WY is already done for us. We already know that one piece is 7, so together those would be 14. WZV is our angle right here, the 34 degrees. And XYZ is this whole angle. So let's use the fact that we have triangles, and in this triangle right here, we already have some angles. We know that we've got 34 up here, and this is 90, and how can we find out the missing angles? We can take 180 minus the 90 we already know, and the 34 we already know, and that gives us a 56. So this angle is 56. Now remember, with a rhombus, the diagonal bisects the opposite angle. So if this is 56, that means that all 4 of those are going to be 56 degrees. So for our question X, Y, Z, they want the whole angle together, so I need to add 56 plus 56, and we get 112 degrees. So moving back to XY, XY in our picture is right here. So I'm going to redraw this triangle a little clearer with our information in there. So in my picture right here, I drew in the pieces that we have, and we have our XVY is the triangle. It's a right triangle. We already knew that this piece right here was 7, and our degree in the corner for angle X was 34. We do know that this angle is 56, but we don't really need both angles. We only need one, so I'm just going to use the 34. We are trying to find the side H, so XY. Now realize that we have opposite and we have a hypotenuse, so we need to use the sine angle ratio. So when we set it up, we've got the sine of our angle, so 34 degrees equals our opposite over hypotenuse, so my H, and then we can cross multiply our top angles together, so we end up with 7 equals the H times the sine of 34, and we have to divide by the sine of 34 on both sides to get rid of it off of the right. So in our calculator, you want to type in this left-hand side, and that gives us our h value will be 12.518. So let's round it to the nearest tenths place, so that would just be 12.5. Number 11, because we know it is a rhombus, we know that the diagonals will be perpendicular to each other. So again, we are creating some right angles within our rhombus. We also know that all four sides are going to be congruent to each other. Using these two characteristics is going to help us to figure out what the x and y values are going to be. If we look at the x's, these are dealing with the sides. We know that all sides in our rhombus are congruent to each other. So let's set those equal to each other, and then you can solve for x. Go ahead, and I want you to find the value of x. You should be setting them equal, and then once you solve it, you should end up with 13 divided by 3, which gives us a 4.3 repeating. So it's kind of an odd number, but if you notice our answers down below, they don't want just the x value. We're going to have to put that back in to find our side lengths. So AB is congruent to all the rest, so that just means that we need to put it back into either of those to figure out what one of the side lengths is going to be. So if we take the BC part of it, we have 4 times this decimal number plus 15, and when we multiply this all out, we end up with 32.3 repeating. So we're going to do 32.3 for the length of that missing side. For angle BCD, we need to figure out what the value of y is going to be. So if you notice, the 12y is written right here in the middle, and we know it's a right angle. That means that we're going to set the 12y equal to 90 because it's in the 90-degree spot. When we divide both sides by 12, that gives us y equals 7.5. So again, we need to plug those back in for the angles. This angle right here is this 4y minus 1. So 4 times 7.5 minus 1 gives me a 30 minus 1, or 29. So this little measure is 29. Remember that that gives us all 4 of those angles since they are cut in half. So angle BCD, then we're adding 29 plus 29 because they want that whole angle all together, and that gives us a 58 degrees. The angle ABC is going to be this whole angle right here. Now remember that all 3 angles need to add up to equal 180 degrees. So if we've got 29 already, this one has to be a 61. So in our picture up here, we have a 61 in both of those angles. So we just need to add 61 plus 61 to figure out this angle, and that would be 122 degrees. For this very last question, we're going to go pretty quick. It is a rectangle again, so remember that all 4 of your pieces of your diagonal are congruent. So because we know these two are congruent, we're going to set them equal to each other. Now when we solve it, we could add our 8k to the other side, so that would give us a 12k plus 62 equals 26. We can subtract our 62 over, and we end up with a negative 36 equals 12k. Divide both sides by 12, and k is equal to a negative 3. Now, they want us to find what the measure of AC plus DB is going to be. So we need to figure out one of the lengths of the diagonals, and then remember they're both the same, so we can just double it. So for AG, if we put this back into negative 8k plus 26, so this is for AG, we get a 24 plus 26, so that is a 50. So if each of these pieces of our diagonal are 50, 50, 50, 50, that means that AC, the whole length is 100, and our DB, the other one, is also 100. That means that the total length is going to be 200.